That tiny little zap can actually damage the board. So we're saying, all right. In order to prevent this, people wear gloves when making contact with the inside of a computer, when making contact with the boards, the motherboards, or any of the naked components. You understand? So in order to prevent that from happening, yeah, that's like as a protective measure. Then we have the number systems as one of the things that we should talk about. Um, if you have technical background, you must have heard this, or if you did elementary mathematics, you would have heard number systems. I think this is one of the reasons you learned it, because one point in your life you might go into computer or computing technologies like that. So it's important to know what the number system is. A number system is just a system of numbering, which is what is implemented in computing, in the world of computing. You must have heard somewhere where they say computer understand only the language of binary, that's zeros and one. I'm going to explain what it means in a bit, but number systems are just the various ways of counting numbers. They are different, there are many of them actually, but the most important ones I think you should know about is the binary. For now, for the sake of this this class and for the sake of elementary computing, is basically binary, decimal and hexadecimal. Binary being counting in either zeros or ones, and decimal being counting from 0 to 9. Hexadecimal is in base 16, where after 9 all the values are now represented with alphabets from A to F, which is also very important. Now understanding these things are very good. You will be needing it if you are working with computers from a low level of abstraction, if you are working with assembly languages, if you are learning to program computers from a very basic level. But it's also important, if you understand this, you can be able to make changes at a very basic level of hardware, and also hardware, software, and also when you're working, with an attack that's memory related. Also, this knowledge can also be very essential. And when you're working with assembly languages, this knowledge will also be very important. And to a very large extent, it is. I can say that you don't have what it takes yet until you've known this. So if you want to know better, you go into that material, and then when we are doing networking, we are going to explain binary systems properly, right, as it relates to computer and transmission. But I'm going to explain why this is very important right now. So when you hear that computer understands binary, that's base 2. What it actually means is that when electric flows into a computer, and communication is done through that, it basically means at a point your 0 is representing no electricity flow, and your 1 is representing a flow of electricity. So considering the electronic components that we have, it is possible to have a logic system where this flow can be regulated, and for every time there is a 0, you allow it to pass, and when there is a 1, you allow it to pass. But this can build into a complex system where there be streams of zeros and ones working and being transmitted side by side with an operational logic circuit that's controlling this particular flow. In another level of abstractions, they begin to make meanings in a way that will not be going into right now. So yeah, anytime you say maybe like a stream of bits of 0 1 0 0 0 1, you're basically saying no electricity, no electricity flow. This can have meaning, right? This can be translated to mean something, and that's how computer instructions are actually being sent from the electronic perspective, from the electronic level. So yeah, it's very important to know this. We are going to delve deeply into it in our coming videos when we go into networking properly. Now we'll talk about computer as a physical unit. It comprises of certain components, the components being hardware, software, and firmware. And the hardware are the physical parts of the computer that you can touch, that you can interact with physically, like your keyboard and your mouse, your your printers, all of those things that you can make physical contact with, the hardware components of your computer. And this can also be divided again into input devices and storage devices and output devices. So an input device are those devices, the hardware devices that you can use to send an instruction into a computer. For example, your keyboard, when you type or you press on your keyboard, you make any gesture on your keyboard, well, of course it's basically pressing, but you are basically telling the computer to do something. So if you press A on your computer, you are trying to say, computer, show me A. What happens is that from the moment you press the computer, an instruction is sent into the memory like that for processing, and it knows how to convert what you press from the physical to represent A on your screen. And this is a whole lot of process from that particular point to the electronic level, where it is converted into that zeros and ones that we explained together, and the processing is carried out in the processor, in the central processing unit, which we'll be talking about shortly. And then it is also stored and outputs to you as information. So everything you're seeing on this screen comes as a result of an input that was given into it. It means I have sat down and typed everything, and then everything is showing to me now in the form of outputs. But any of those devices, like a mouse, like a keyboard, like a scanner, like a microphone that I'm using to speak into the computer now, that you use to send instructions to the computer, is an input device. An output device can be your monitor, your printer, speakers, those things that bring feedback to you, that brings outputs to you based on the things you send into it, right? Those are output devices. There are many other kinds of output devices, but if you understand this, you can think about the other ones on your own. You can also read deeper in more details with the other materials. Then there are other storage devices that are used to keep information for you, like your hard drives, your solid state drives, that's the SSDs, and USB drive, your flash drives. There are floppy disk and diskettes that are not included in the slides, but they were once technologies that were used as storage devices as well. The other ones, they call them RAID devices, which are also collection of storage devices. The first material I sent has information on that. So yeah, those are storage devices. But I'm very sure we are more familiar with these ones. So these ones keep information. You know how you go into your PC, and then that movie you downloaded one time is still there. You can go and then you can watch it anytime. It's because it is stored somewhere in one of those storage devices. It can be a hard drive, or a solid state drive, or even your flash drive, or your memory card. Your memory card is also a storage device. Yes, there are any of them that you could use. So then we are going to talk about internal components. They are also hardware devices, but they are not physically visible. They are inside your computer. Example is the CPU, the RAM, the motherboard. The GPU is a processor, also a graphic processor, and the power supply units like that. Most of them are inside your computer. A power supply unit for a laptop is outside the computer anyways. It's called the power adapter, what we know as the charger, right? But these ones are also hardware. So by the time you open up your PC, open up your desktop, when you open it, you're going to see these things. You can actually literally touch them. That makes them qualify as hardware devices also, right? Okay, we are going to be explaining them in more details in the coming slides. So for now, we can move on to the other parts. So the CPU we talked about, and the RAM we talked about, the motherboard and the other storage devices. So the CPU is the central processing unit. The CPU is where the processing of the instruction is carried out. Like earlier I talked about you sending instruction into the computer by pressing A on your keyboard. How does the computer understand that it is A you press? It means that instruction has to be carried from that point on your keyboard and sent into the processor for understanding. If it is a mathematical operation you did, like a 1 + 1 operation, you press 1 + 1, how does it know that the answer is going to be 2? The computer processor is the one who makes the calculation. Inside the processor there is something they call the arithmetic logic unit, where arithmetic calculations is actually carried out. So it's responsible for doing that one plus that one at a very, very basic level, and then finding the answer and sending the answer back to you to be